Okay, in this video I'm going to give a basic introduction to the Cartesian product of sets. I'll tell you what it is, and I'll tell you how to count the number of elements in the Cartesian product. It's going to be fairly straightforward, as you'll see. Let's take two sets, A, which is defined as containing three elements, A, B, C, small lowercase a, b, c, and B containing the elements 1, 2, 3, 4. What I'm going to do now is I'm going to take the Cartesian product of these two sets, and it looks sort of, and conceptually it's sort of like multiplying these sets by each other. We're going to have A cross B. So this is A cross B is how we say that. And the Cartesian product of these two sets is going to be the set of ordered pairs. And I'll show you what an ordered pair is by example here, where the first element of the ordered pair comes from the set A, because it's the first one in the product, and the second element of the ordered pair comes from set B. And we're going to take all combinations of those. And so I'm going to write ordered pairs in parentheses with commas. So I'm going to have A, comma 1 is the first element of this set. I'm going to have A, comma 2. I'm going to have A, comma 3. And I'm going to put these things in parentheses separated by commas. Okay? And then I'm going to have A, comma 4. And then I'm going to move on to B and go 1 through 4 and C 1 through 4. B1, B2, B3, B4. And if I need a new line, I can just wrap it around. C1, comma, C2, comma, C3, comma, C4. And so it's a little bit tedious, but not too bad. And I can put my curly bracket here. And you can see now that I've got 12 elements in a set, 4 from each of the letters A, B, and C. And so the size of the cross product is 12 in this case. And we see that the size of A is 3, and the size of B is 4. Size is also called the order. And it turns out that the size of the cross product is the product of the size of the two sets. Okay? And so this object, this mathematical object that we have here, is called an ordered pair. Okay? And is essentially a list of two elements. Okay? Very often what we're going to do when we write cross products is we're going to use a shorthand notation. We're going to abbreviate as A1. And you can see that that's going to save a lot of writing. I had a lot of parentheses and commas here, and I could then write the set A cross B as follows. And I'm going to use a little bit different way of denoting it. Look at my great big left-hand parenthesis, and I'm going to write A1, A2, A3, A4, B1, B2, B3, B4, comma, C1, C2, C3, and C4. And I'm going to put a great big bracket around there. Okay, so whether I use small brackets or large brackets doesn't matter. And the nice thing about the way I've written this set is that it shows the pattern where I have a column with all ones, a column with all twos, threes, and fours. So in columns, I have numbers, and then I have a row with all C's in it, and a row with all B's, and a row with all A's. So you can see why we call it we can think of it as set multiplication because the number of elements is the product of the size of the two sets, and because it does exactly what multiplication does, is it gives us the number of rows in the column. So you can think of this picture for the product 3 times 4, something you've known for a long time probably, and you can think of this as this Cartesian product as being just analogous to that. Okay. Now it's important to remember that these are ordered, and so for example, A1 in our abbreviated notation is an element of A cross B, but A1 is not an element of B cross A. Something that isn't B cross A could be abbreviated 1A, would be an element of B cross A. So multiplication of numbers is commutative. You can multiply in either order, but when you take Cartesian product of sets, in general it is not commutative, and B cross A is not equal to A cross B in general. Okay, so there's a basic introduction to Cartesian product of two sets. This can be generalized to multiple sets, and we'll deal with that in another video.